Hello, my name is Bernardo Marques Costa, and I'm here to present a work done at University of São Paulo, a joint work with Aime Nóbrega, Adailton Araújo, and Ricardo Marcacini on link prediction from heterogeneous opinion mining networks with multi-domain applications. Opinion mining and opinion analysis is a relevant topic on NLP, having a lot of applications on both industrial and academic contexts, but it also have extremely important implications on the study of social interactions. One of these applications is the study of customer reviews on products or services, where the tasks involve identifying both product features mentioned in the sentence and the sentiment carried by the text. In this scenario, recent studies on opinion mining from text data usually rely into two different steps. The first step is to identify which feature of the product or the service is being mentioned in the review, and the second step lies on the sentiment analysis of the text. As an example, the sentence written below the slide have an entity the term laptop. So the reviewer is talking about the product laptop. The first aspect of the entity that the user mentioned is screen, associated with the term excellent. Therefore, that brings a positive connotation. Another analysis is done to the second aspect brought by the reviewer, about the feature battery, associated with short-lived, with a negative connotation. For both steps on this approach, pre-trained models such as BERT, Roberta, and Diberta are used, and they are adjusted with fine-tuning process to fit into the domains of the task. However, this brings an interdomain problem. To illustrate the problem, we can see that the term light has different meanings. In the first case, it can be used to describe lighting of an environment, and the other context can characterize the weight of an object. With that, a question comes to our mind. And this question results on the research done on this paper. How can we create relationships between different domains? In our work, we try to create those relationships with the construction of a heterogeneous network that combine different domain features. Therefore, we create a network that has a set of nodes and links with the following properties. Nodes are separated in three different types: text nodes, aspect nodes, and model nodes. And links are constructed to resemble the relationships between nodes of different categories. In that way, we are able to design this graph structure. This thing so-called heterogeneous opinion mining network has the following structure. The first layer of our network is composed of review nodes, where each node represents a text about a product or a service, for instance, written by a customer. The second layer contained in the graph corresponds to aspect nodes that brings product or service features. Finally, our last layer represents the models, that is, deep learning aspect extraction models, used on the construction of the graph. All links in the network tries to model in the best way possible the relationships between user reviews, aspect observed on the training sample, and aspect extracted in the test set. Therefore, to create a link, we consider the following rules. A link between review node X and aspect node Y exists if such aspect emerge on X text. Added to that, a link between aspect node Y and model node D exists if such model was able to extract Y from any review text. Our initial expectation on our experiment is that the graph structure captures relevant information across different domains, making a step forward on the interdomain problem mentioned earlier. So to simulate the multi-domain application character of the task, we trained each model on a single domain training set. For instance, we trained a model on WhatsApp train set, another model on eBay train set, and so on. Then each model were fitted with a test set of an application different from the one it trained. Therefore, testing each model capability or flexibility across domains. Later, all of the single domain trained models were combined into the network structure to create a complex network that tries to deal with the multi-domain aspect. or choosing deep learning model to extract aspects from user reviews is ReBERT, a requirement extractor BERT-based token classification model. One ReBERT model is trained for each one of the 8 datasets, making 8 different models. Digging a little bit more deeply into our heterogeneous network, it is constructed as the images side, where we have all trained datasets sentence pictured in the green block. Associated with it, we have positive samples and negative samples. The yellow block represents all test sentence from the entire test dataset, and they are associated with the aspects that have been extracted from it when applied one of the models. Finally, an aspect node from training set is associated with a model if an ReBERT trained model has identified it as an aspect in at least one text, one sentence. After the construction of the graph, we use a graph convolution neural network to explore this link prediction and embedding learning of this particular network. And we do so in 2 different ways. We do that without language modeling, where we rely only on the relationship of the nodes in the network, and with language modeling, where we enrich our nodes with embeddings generated by sentence transformer, giving context to every sentence and aspect nodes. As we can see on our evaluation results that concern accuracy of the link prediction task, our network topology was able to capture relevant information, leading to a high accuracy on this task. In that way, we have now some evidence that the embedding generated on the GCN can be used to bring more valuable information of the nodes and the relationship between them, information that can be used on different applications. One interesting thing to notice is that language modeling, that is, with external features enrichment, brings a significant difference in scenarios with low amount of training data, while GCN applied without language modeling have done a slightly better job on the opposite scenario, where we have more training data. So in conclusion of our work, we create a new approach to represent and naturally combine different domains applications on tasks in opinion mining, where we were able to generate embeddings based on heterogeneous network that are potentially helpful for mining opinions in a wide range of applications, such as classification, clustering, and similarity search. Future work involving investigating how the GCN embedding and possible combinations with language modeling or enrichment can lead to better results in other tasks. And that's it for my presentation. Thank you very much for your attention.